Hi everyone, today we are solving LeetCode 383, which is ransom note. This question tells us that we're given two strings, ransom note and magazine. We're asked to return true if ransom note can be constructed by using the letters from magazine and false otherwise. Each letter in magazine can only be used once in ransom note. Let's go through the examples for this question that were given on LeetCode. So example 1 gives us ransom note, which I'm going to refer to as RN here for simplicity, is A, and magazine, which I'm going to refer to as mag, is a string B. Can we construct A from B? Clearly not, so we're going to return false. In example 2, we're given ransom note as AA and magazine as AB. Can we construct ransom note, which is AA, from AB? No, we can't, because we have two A's here and we only have one A here. So we return false. And in the last example, we're given ransom note as AA again, and magazine is AB. Can we construct ransom note from the letters in magazine? Well, yes, we can, because magazine has the letters AA, and we can use those two letters to construct ransom note, which also has AA. So we'll return true. Okay, so the next part of this is let's figure out how we're gonna solve this or create the algorithm we can to solve this. So the first thing I would consider is, since we need to check if we can create ransom note from the letters in magazine, let's store the letters of magazine in some sort of data structure that we can use. In this case, we can use a hash map. So store letters in magazine in hash map. What this is going to look like is this. So I'll go through example 2 using this. So I'm going to call this hash map magmap, short for magazine map, and we're going to store A and B in there. So A is a key and its value is 1 because that's the occurrence. There's only one occurrence of A and only one occurrence of B. So B is also 1, and that's our magazine map. The next step that we're going to use to solve this problem is we're now going to iterate it through ransom note, and we're going to check if that letter or each letter exists in the magazine map. If it doesn't, we are going to return false right away because clearly there isn't a match. If, however, it does exist in the magazine map, we're going to decrement one of the values of that letter in the magazine map. And upon the decrementation, we're going to check if the count of that letter falls below 0. If it falls below 0 and we're negative, that means we never had enough letters for magazine map in the first place to create that. So we can return false in that instance as well. Otherwise, if we make it through all of these and we make it through the loop, then we can return true at the very end because we didn't run into an instance in which we couldn't create ransom note from the letters in magazine map. So the second step is to just iterate through ransom note. I'm just going to call it RN here, and check if it exists in magmap. If not, return false. If true, then we can decrement magmap. Upon the decrementation, check if count falls less than 0. If true, return false. Otherwise, we're just going to return true. Okay? And that's our core algorithm. Now let's work on going through an example of this with the algorithm we've laid out. So I'm going to go through example 2 first, and then we can go through 3. In example 2, we already had it. So the first step is to store the letters in a hash map. So our mag map is going to look like this. We have A and B. Okay. Now second step is to iterate through Rn. Rn is AA. I'm just going to write this out like that so we can think. So the first letter we are on is A. We check if A exists in the mag map. It does, right? So if true, now we decrement the mag map. Okay, so let's put that to 0. We check if the count is less than 0, and if that's true, we return false. Well, 0 is not less than 0, and so we keep going. We don't have to return false. The loop continues. Now we're on the second A. We check if A exists in mag map, right? If not, return false. If true, it does exist, so we decrement the mag map. Again, this goes to -1 now, right? And now we check if the count is less than 0. Well, yes it is. It's -1. If that's true, return false. Okay, cool. In example 3, it's very similar. Our mag map looks like this. Our A count is 2, and our B count is 1. If we go through AA again, we can check if A exists in the mag map. It does. We decrement it, and then we're on to the next one. It's not less than 0, so we don't have to return false, and we can keep going through the loop. On the second one, we decrement again. We're at 0, and now we're finished. But upon the decrementation, we have to check if it's less than 0. It's not. It's still 0, so we don't have to worry about that. And now we've exited the loop, and we can return true. And that is the gist of this problem. Let's code it out. Alright, so the first step of our process was to iterate through each letter in magazine and store its occurrences inside of a hash map. So all we're doing here is we're iterating through each letter in magazine. We're checking if it already has been initialized in the magazine map. If so, then we're going to increment its occurrences. If not, then we initialize it. The second step of this process is to now iterate through ransom note and check if it exists in magazine map. And then if it does and it's greater than 0, or its occurrences is greater than 0, then we're going to decrement it accordingly. If not, then we can return false right away because clearly magazine didn't have the letter we needed. And then ultimately, if we make it through all of this without returning false, then we know that we have been successful in creating a ransom note from the letters in magazine, and we can return true. Let's give this a run. Passed all their test cases. Let's try and submit it. Awesome, there you go. The final thing to discuss is the time and space complexity. So for this question, the time complexity is O of m plus n. And this is because in isolation, we iterate through both ransom note and magazine, which are m and n letters in length respectively. The space complexity is O of n linear, where n is the length of magazine since we store each letter of it in a hash map.